Hi guys! So last video we ended up talking about the cerebrum. We talked about the cerebral hemispheres, all that entails with that part of the brain. We talked about the lobes, we talked about the functions of the lobes. So now we're going to talk about a couple of different parts of the brain to finish off section 6.3. So we're going to talk about today the dicephalon, and this is also known as the interbrain because it's located so deep inside of the brain, and you can not really see it unless you really move around the cerebral hemispheres because it's just tucked in there real good and protected. But the dicephalon has three important parts to it, and we're going to talk about what they are and what their functions are. So the three parts of the dicephalon are the thalamus, the hypothalamus, and then the epithalamus. So let's start off with talking about what the thalamus does. So if you can see that, the thalamus, let me zoom in a little bit, it basically is a communication station between your body and then the cerebral cortex, which is pretty much the cerebrum that we talked about, like the left and right hemispheres, and it helps to relay the information between the sensory and then the motor neurons so that they can get information through the sensory neuron and then transfer it so that the brain can respond with a motion through the motor neuron. So what exactly does the roles of the thalamus entail? So the roles of the thalamus, the roles of the thalamus include regulating the body's states of arousal. Basically, this means that it regulates your sleeping cycles, when you're awake, and then also when you're highly alert. So this could be due to medications that you take. It's kind of like you have an extra sense of your being. It could also due to drugs that you take that are not good for you, and then kind of psychosis and meditation and stuff like that. So these are ways that you can be highly alert in your consciousness. So just being extra aware of yourself, pretty much. So those are the things that the thalamus does and the roles that it plays. And then if you look at your hypothalamus, we can kind of see what the hypothalamus does. So the hypothalamus is probably something that you've heard more commonly than the thalamus and then the epithalamus. So the hypothalamus is actually really small. It's like the size of a pearl or a pea, very, very tiny. And this is part of the autonomic nervous system. So it helps to regulate things that you don't really have to think about. So like your heart rate, your metabolism, your blood pressure, which is what BP stands for, your hunger, your thirst, your body temperature, how energetic you are. And then this is also where you kind of have your pleasure. Some of it can come from this, from the hypothalamus. So that kind of encompasses what the hypothalamus does. All right, and then the lastly is the epithalamus, and this is pretty much includes your pineal body or your pineal gland, and then the roles that the epithalamus plays are to regulate melatonin, which is a sleep hormone. So sometimes people who have a hard time sleeping, doctors will recommend taking a melatonin vitamin kind of thing that kind of just regulates this hormone in your body to help you get a restful amount of sleep. And then your melatonin is also secreted by your pineal gland, which is part of the epithalamus. So these are just three parts of your dicephalon. Like I said, your dicephalon is tucked into your cerebral hemispheres, like you see up here. And then there's three parts to it: the thalamus, hypothalamus, epithalamus. Thalamus over here mainly has to do with being a station where you can relay information coming in from the sensory and going out through the motor, and then it's just regulating being awake or while you're asleep, or just extra sensitive to your surroundings or to your body. Then you have the hypothalamus, which I said is super small but has a lot of functions, especially in regulating things that you don't really have to think about. Like you're not thinking, hey, give me a lot of energy level right now, body, I really need it, or hey, make sure my heart rate is beating at the right rate, increasing when I'm exercising, decreasing when I'm at rest, and your blood pressure, so on and so forth. Those things you don't need to, they're not voluntary, they're involuntary, so they're autonomic. They automatically do what they need to do. And then you have your epithalamus, which helps with regulating your hormones in your body, especially like melatonin, and it's secreted by your pineal gland, which is part of the epithalamus, and then that's just to make sure that you are getting the rest that you need. All right, so let's move on. All right, guys, let's talk about the brainstem. So some things you need to know about the brainstem is that, one, it's actually pretty small compared to the rest of your body, but it holds really, really important parts to it that control a lot of things that your body does, like breathing, helping you see vision, hearing, with coughing, stuff like that. So damage to this area can be very detrimental to your state of being. But 3 parts of the brainstem are your midbrain, your pons, and then your medulla oblongata. So if you look at your textbook on page 212, you will see this image of your brainstem. So you can see the dicephalon that we just talked about in a couple seconds ago, and then you can see the midbrain right here, you see the pons, and then you'll see your medulla oblongata right here, and then the start of your spinal cord. So this is kind of the bridge between your brain and then to your spinal cord, okay? So this, right below the dicephalon, is the midbrain. The brain stem, your midbrain, pons, and medulla oblongata. So let's dive into each part of the brainstem and see what they do and what they control. So the first thing that we're going to talk about is the midbrain. So the midbrain is superior in the brainstem, meaning that it's the topmost part of the brainstem. The pons and the medulla are located beneath the midbrain. And this is kind of like a relay station for your sensory and your motor impulses. So this is kind of where your sensory impulses are going to come in, and then your motor impulses are going to go out. So what does it relay, right? So the information that this part of the brain is going to, brainstem is going to relay, is your vision, your hearing, motor activity, your sleep and wake cycles, being alert, kind of like how we talked about with the dicephalon, high alertness in your consciousness, and then temperature regulation in your body. So these are all covered in your midbrain, so super important. And then you have your pons, all right? So your pons is going to be below your midbrain. So if we look at your picture over here, we said that this was the midbrain, this kind of yellow looking thing. And then this bigger part is known as the pons, all right? Now the pons pretty much has one main function, and that's to regulate your breathing, all right? That's the main pretty much synopsis of what the pons does. Make sure that you're breathing well to get enough oxygen to your brain, and to regulate your breathing so that you can catch your breath and have the ability to do so. And then last but not least is your medulla oblongata, which if you saw over here, is this purple looking thing right there. And then this has a couple things that it's going to regulate. It's going to regulate your heart rate, your blood pressure, which I initially BP, your breathing. It's also going to control your reflexes for when you cough, when you sneeze, and then also for vomiting. So it's going to help the reflexes for all of these 3 things as well. All right. There's also something called the reticular formation, and basically what the reticular formation is there's another part to the brainstem, and that's the reticular formation. It pretty much covers the brainstem on the outside all the way through. So it's going to cover the entirety of the brainstem, and this is going to be to help regulate your waking up from your sleep and then being super aware of your surroundings and your state of being, kind of relating back to the dicephalon. People who have brain injuries typically can survive and thrive and get better as long as their brainstem, which the midbrain, the pons, and medulla oblongata, is able to still function and do its, its regulation or regulatory things. So like making sure that your pons is able to regulate your breathing, making sure that your medulla oblongata is able to control your reflexes, making sure your midbrain is able to relay information regarding your vision, your hearing, your motor activity, your temperature regulation. So all of that is super crucial to a person's well-being. So for people who have brain injuries, as long as there's no severe damage to your brainstem, pretty much that person will be able to function, as long as obviously they're well nourished, they're hydrated, and that their brain can recover, and that person can recover pretty well with that kind of brain damage that is not fatal or has severely struck the brainstem. Cerebellum. So the cerebellum is located below the occipital lobe. If you look on page 208, you can see on the bottom figure the cerebellum right here. So the occipital lobe is this green thing right here, and then below that is the cerebellum. All right. So what does the cerebellum actually do, and what are the functions of the cerebellum? So the cerebellum functions is that it helps to coordinate body movements. All right, so it helps with balance. It is going to help with balance and coordinate body movement as long as it can get proper information from your inner ear, your eyes, and then your sensory receptors in your body to help coordinate this movement and balance. So your inner ear, like your vestibular canal and stuff, they help severely with balance. You guys probably heard me talking about how my vestibular canal doesn't work as well on one of my ears than the other. So I do have this sense of off balance feeling a lot of times, especially when I'm triggered by an illness or stress or something like that. So that affects my balance because my inner ear is kind of being thrown off a little bit. Your eyes, the information that your eyes are sensing from your surroundings can also help with balance. For example, are we moving? Are we not? Is the object I'm looking at moving? Is it not? So a lot of information is being sent to your brain through your eyes, and then also sensory receptors around your body, your senses, like your touch, your feel, whatever. All of those help in with your cerebellum detecting body movement and giving you balance. So another cool thing about the cerebellum and its function is that your cerebellum is always monitoring your position of the body and then the motion of your body. So what this basically means is that if you are doing a motion or in your position where your cerebellum has not intended to happen, so maybe you did something that causes your body to, be twisted in some kind of weird way that you normally can't do or shouldn't be done, your cerebellum will actually correct itself so that your body can come back to its normal state. So this happens if someone injures themselves. Your cerebellum is going to really work hard to bring your body back to the state of normalcy so that you don't further hurt yourself. Or if you're doing a movement, your body is going to really try that. Say you're jumping, making sure that you're landing in the right position so that you're not throwing yourself off to a different kind of state of position that you normally wouldn't be in. So cerebellum, super important, located below your occipital lobe. It is very similar to how your cerebrum is structured with the great cortex, and it also has convolutions that we talked about in the previous video with your gyri and sulcus and stuff. So it's not a smooth surface, it is a little convoluted. And then it also has dual hemispheres like your cerebrum, in that it's separated from left and right. And then, like we talked about, important function of the cerebellum is that it coordinates body movement, so it helps with your balance. And from there, let's move on to the next thing. The meninges are very, very important to your brain. You probably heard of this in regards to meningitis, which was a vaccine that a lot of people had to take. I was required to take it before I went off to college because of how easily it can spread. And the main reason that this was a serious vaccine to really take was because it affected your meninges of your brain. And so what basically meninges are protective layers that cover your brain and your spinal cord. And there's 3 layers that go with this. The first layer is the dura mater, which kind of actually means hard mother. Why they named it that, I don't really know. But probably because it's the outer layer and it's a lot more durable than the other layers. But like I said, it is double layered. So it's located right under your skull and it surrounds your brain. The 2 layers are the outer layer, which, like I said, is right under the brain, and then there's another one that goes right underneath. The second layer of this dura mater actually goes down to enclose around the spinal cord. So if you guys flip with me to page 213 in your textbook, you will see this image right here. Let me see if I can show you that. And this image right here will show you that if this is a skull, this kind of cream color looking thing is a skull, you can see the dura mater is this light purple and then a little bit more purplish layers. These 2 layers are the dura mater. So the first layer of the dura mater is located right underneath the skull, and then the second layer of the dura mater is right underneath the first. And the second one you can see kind of sinks down between the brain to go down into the spinal cord as well. So let's talk about the next layer that we have right underneath the dura mater, and that's the arachnoid mater. And this is a web-like tissue, and it's going to also have a space that is going to be located underneath this tissue or underneath this matter, and that space is going to be filled with something called cerebrospinal fluid. And this fluid is very important because this is what is cushioning your brain and your spinal cord, so that it's preventing it from injuries, it's protecting it from different things that could try to get in. So it's very important for the protection of your brain and for your spinal cord. So now that we have the first 2 down, let's talk about the last matter, or the last layer of your meninges, and that's your pia mater. And this is the innermost layer of your meninge, and this is going to attach directly to your brain and your spinal cord. So this is called the gentle mother. So we said that the dura mater, which is located right underneath the skull, is called the hard mother. It has 2 layers. It has the outer layer that's right underneath the skull, and then it has this inner layer that goes down to the spinal cord. So if we look here, skull, dura mater, the second layer of dura mater goes all the way down, so it can wrap around this spinal cord. Then you have your arachnoid mater that you can see with this like pink color right here, and that also will go down. And then you have your pia mater, which is this covering right here, and that is going to be directly on the brain itself. And then you can also see the subarachnoid space right here, which is what is filled with the cerebrospinal fluid, so that it gives your brain extra cushioning and extra protection. So there's something else that's part of your brain that is very important to control what goes to your brain, and that is called a blood-brain barrier. So basically what the blood-brain barrier is that like the rest of your body, your brain has capillaries that help to protect the brain, but also help to nourish the brain with water, nutrients, and selective other ions and stuff like that. And the selective part of these capillaries is pretty much called the blood-brain barrier, as in it is a barrier towards things that your brain doesn't need, that could cause damage to your brain, that was not intended for your brain, and so on and so forth. So obviously capillaries that go to your brain are essential, like it is for every other part of your body, because they, like I said, carry nutrients, and then they also carry waste away from the brain from cell metabolism. But 20 to 25% of the blood that's in your body is actually circulating around your brain, which is kind of crazy to think. So sometimes, a lot of times that we get headaches, like migraines and stuff, is because you have a lot more blood that's gushing around your brain than intended, and so you can get pretty bad headaches. So what are some things that your blood-brain barrier protects your brain against? So it can protect your brain against hormone surges that can kind of drive you crazy, throw you off your homeostasis in your brain. It protects against certain ions that are not needed in the brain, and not all nutrients are actually intended for your brain. So it can protect against that. What is allowed to pass through this barrier is water, glucose, some essential amino acids that can actually help your brain process things better. There are some vitamins that you can take that have special amino acids that will help just with thinking, with anxiety and stuff like that. And then there are also some things that can pass through this blood-brain barrier that is also not the best thing. So like bloodborne alcohol can go into your brain and can cause damage if it's in an excessive amount. Nicotine, for example, from certain drugs like cigarettes and stuff, that can pass through this blood-brain barrier, and it can be pretty much, it can have some serious effects to it. And then there are fats and some anesthetics that can also pass this barrier that can influence the brain. The last thing I want to talk about in section 6.3 is the spinal cord. You guys probably know by now, without having to take anatomy, how important the spinal cord is. So the spinal cord basically is going from your brainstem and it goes to the start of your lumbar region of your spine. And there are important functions that the spinal cord has. For example, it is the sensory, it's where your sensory impulses come in, and then your interneuron will help to switch it to motor impulses that will go from your brain to the body part that needs it. So we talked about in the previous chapter how, and in the previous sections of this chapter, how your body is able to take sensory information from the surroundings, like from your skin, and then it can go to either your brain or just your spinal cord, and then it will change to motor impulses that tell your body part what to do. This is really important for the spinal cord to relay information that's coming in, and also to relay information from the brain out. The spinal cord is also protected like the brain, and it's protected by the three meninges that we talked about. It's protected by the dura mater, the arachnoid mater, and then the pia mater, and then also has a cerebrospinal fluid to help cushion the spinal cord for extra protection. Now the exterior of the spinal cord, if you ever see SC, that's just spinal cord. The exterior of the spinal cord is myelinated, so it's going to look white. And we talked about how white means it's myelinated, gray means it's not myelinated. And then it also has a part that's gray matter, kind of looks like a butterfly. And then in this gray matter is where you're going to have neuron cell bodies, and also the interneurons in the middle. So remember when we talked about the interneurons, if I touch something that's really hot, my sensory impulses are going to come and connect to the interneuron, and then the interneuron is going to kind of be the relay station between the motor neuron and the sensory neurons. So once that information comes in from the senses of, oh, she touched something hot, it's going to go to the interneuron, and then it will go from there to the motor impulses, so that it will cause my hand to move away from whatever that object is that's causing me harm. So I want to show you guys on page 214 a quick look at what this kind of looks like. So if you see that this is your spinal cord in full image, you can see that you have the white matter, which is kind of the surrounding part of it, and then this butterfly looking thing is the gray matter. So it kind of says it over here, gray matter, and then this is the white matter that's surrounding it. And then you can see that this is the dura matter, this outside part, the arachnoid matter, and then you have the bottom part, which is the pia matter right here, where it says pia. And then we're going to talk about what these dorsal, ventral, lateral up here really mean in regards to the spinal cord. So the white and gray matter in the spinal cord are named for their location. So there's 3 locations. You have the ventral location, which is the front part, anterior, and then you have the lateral, and then you have the dorsal. Remember I said dorsal fin of a fish is always on the back, so it's going to be the posterior part. So let's go over these locations and what they're doing as a function. So in the ventral part, the main function of the ventral part of the spinal cord is that it's going to transmit sensory and motor impulses. So if you look over here, you can see that the ventral root of the spinal cord is towards the front versus the dorsal, which is towards the back. So the ventral part is going to transmit sensory and motor impulses. And then you have something called the lateral, which is also going to do the same thing as the ventral, which is going to transmit sensory and motor impulses. And then last, but certainly not least, is the dorsal, which is on the back. And this one's mainly made up of white matter, and this is going to carry sensory impulses to the brain. So if we look at it over here, you can see the lateral right here, sensory, and it's going to carry sensory and motor impulses. You have the ventral here, and then you also have ventral on the other side, which is carrying the same thing, sensory and motor impulses. And then you have the dorsal here, and then the dorsal also up here, which is going to be relaying sensory impulses to the brain. So all of this plays together in order for your body to function and to have the correct movements that it needs. And another thing that I just wanted to point out was down here in purple, the lateral, ventral, and dorsal projections that you see, they're also referred to as horns. So sometimes you'll see, like right here, the dorsal horn of gray matter, the lateral horn of gray matter, the ventral horn of gray matter. So they're all kind of going to reference pretty much that they're projections of whether it's lateral, ventral, or dorsal. And that will make up your spinal cord.